given B is the midpoint of AC and C is the midpoint of BD, we want to prove that segment AB is congruent to the segment CD. So like with most of the proofs we've looked at already, the first step is going to be the given. So our statement here is B is the midpoint of AC and C is the midpoint of BD. And like with most of ours, the first reason here is given. So this is given to us as a fact. That means it must be true. Our next step then either wants to use this given or these givens, or to look at our diagram and write another statement that might be true. And there's a few different things that we could do with this. One of them would be to look at what we are trying to prove, which is that AB and CD are congruent, and recognize that if we're going to say AB and CD are congruent, somewhere we're going to have to make a statement about AB and CD. So on this proof specifically, probably the best way to start is to think about, well, if B is the midpoint of AC, what does that mean? What does it mean when B is the midpoint? It means that it's in the middle. It divides the segment AC into two parts that are the same, or in half. Right? The same is the part that we want to focus on here. Not just that they're the same, but they are actually congruent. Right? So if B is the midpoint of AC, then the segments formed with B and AC must be congruent. That is, segments AB and BC. So segment AB must be congruent to segment BC. And C is the midpoint of BD. That means that C is that same thing for BD. In other words, we create two segments that are the same length. BC is congruent to CD. And the reason here, how do we know that given B is the midpoint of AC, that AB must be congruent to the segment BC? This is the midpoint theorem. Now, if you had thought to yourself, well, why isn't it the definition of midpoint? And that's a good question. So the first part here is that the midpoint theorem does specifically say that if you know something is the midpoint, then it must mean congruence. Whereas the definition of midpoint implies more of an equality, that the two things would be equal. And so if at one point you wanted to say that AB is equal to BC, but you didn't want to say that they were congruent, that you would use the definition of midpoint for. But if you want to say that segments are congruent based on something being a midpoint, then the midpoint theorem is the right one to go with. So it has to do with being congruent or equal. Now note, it would not be difficult to change segment AB is congruent to segment BC over to equality. You can just do it and then write definition of congruence if we ever needed it. Our third step here, since AB is congruent to BC and segment BC is congruent to CD, note that on both of these, we have a segment BC. And if AB is congruent to BC and BC is congruent to CD, then AB must be congruent to CD. And how do we know that? Given congruence of the same segments, this is the transitive property. And throughout your proof, you should always ask the question, are we done? Or when are we done? Well, we are done when we have proven, when we have led to a statement that looks like this. Segment AB is congruent to segment CD. We have segment AB is congruent to segment CD, and therefore we are finished.